In this video, we will try to understand the basic concepts of linear programming. Linear programming is an important topic in operations research. But before going to study the basic concepts of linear programming, we first understand what kind of information or what kind of concepts we have learned from the previous studies. So in our previous knowledge, we have been solving the problems in which we are asked to find maximum or minimum of a function in which only one variable is involved. For example, f of x is equal to x cube minus 3x square. Now, the job of doing finding maximum or minimum value of this function f of x was done with the help of derivatives which come from calculus. It is point to be cleared that the methods of calculus are here just for revision purposes. They are not going to appear in linear programming, but several terminologies which were not labeled or which were not named before introduction to linear programming, they are common, similar as in linear programming. Let's see how this problem was solved with the help of calculus. Using derivatives, we differentiate this function f of x with respect to x and equate the derivative equal to 0. And this equation gives us the value of variable x. This value of variable x gives maximum or minimum value of the function. Such points were called stationary points. We also solve the problems of finding extreme values of function of two variables, and this job was done with the help of partial derivatives, derivative of f with respect to x keeping y constant and derivative of f with respect to y keeping x constant, and both equating to 0. We got the ordered pair of values of x and y, and this pair gave us the maximum or minimum value if it was present there. In addition to these two examples, we also solve the problems in which we were asked to find extreme values of a function, and along with that, the variable x was also restricted to stay within a given range. Here in this example, function f of x was actually a trigonometric function, and we were asked to find the maximum or minimum value of this function, but the search was, or the determination of the values of x was determined to a range from 0 to 2 pi. Again, we solved this problem with the same information, with the same method, that is derivative equal to 0, and we got value of x. But solving the equation f prime of x equal to 0, the resulting value x were not supposed to strictly lie in the interval 0 to 2 pi. So some extra effort was made in selecting only those values of variables x which were belonging to this interval. Similarly, in the functions of two variables, we also did the same thing as in the example number 2. We equated the partial derivatives equal to 0 and found the point xy. Again, this point of x, or this point xy, resulting point xy was actually required to satisfy this additional condition, that x plus 2y equal to 7. We again made a choice by doing some extra effort and selected only those combinations which satisfied this additional condition. And these are the problems which we have solved in previous levels, especially at intermediate and undergrad levels. But we are interested, rather than solving such problems, we are interested in extracting the terminologies which were unnamed while solving such problems. Let us explore what are the essential components of problems in which we are asked to maximize or minimize a function. So we study the components of such problems which we already know how to solve. The first task and the first component is the assignment, job assignment. The job assignment was to maximize or minimize a given function, or when we don't know whether the function will have maximum value or minimum value, or it may have both values, then the word extreme values were used. So the first task, major task, actual task was to maximize or minimize the objective function. So the first task is maximum, finding maximum or minimum in a given function. And the second component was the function itself. In all four examples we saw, there is a function depending on one variable, two variables, and it may be a function of several variables. This function, this function appears in almost every problems every problem in which we are asked to maximize or minimize the given function in mathematical form. This function is known as objective function. Now, next component is the very important component, that is the variable involved in the function, independent variable, or two independent variables, or there may be a case in which more than two variables may involve. These variables, actually, first we determine the value of these variables, and these variables give us the maximum or minimum value of function. These variables were actually called independent variables in the previous studies, but they are also called decision variables. And next part is the not appearing in example number 1 and 2. Next part is we can see in the example number 3 and 4, that is the additional condition which is to be satisfy the values of the variable or the Cn variables. In example 3, the additional condition is that the x should lie in the range from 0 to 2 pi. And example number 4, x and y be such that which also satisfy the equation x plus 2y equal to 7. Such additional conditions to be satisfied the solutions are called constraints. So these four components of a problem in which we are asked to maximize or minimize a given function, these four concepts already existed while we solve these problems in our previous levels. So these four terminologies already existed, but now they are very crucial. They will appear again and again, and we can identify these terminologies, these concepts from in the also in the linear programming. Let us properly define these terminologies for the purpose of reference in linear programming. The first terminology is optimization. That is the basic component of the problems we have been dealing with. That the process of maximization or minimization is in general called optimization. And then the function which is to be maximized or minimized is called objective function. And the next is the existence of constraints. And we saw that these are the additional conditions to be satisfied by the solution while optimization process. And the fourth component is the extra effort, which results in selecting the solutions, the values of the decision variables, which satisfy additional conditions. That set of solutions, or that solution which satisfy all the given constraints, is called feasible solution or feasible set of solutions. Next is the optimal solution. Obviously, our target was to find such values of x and y which maximizes or minimizes the objective function and also satisfy the constraints. Mean the solution which has two characteristics. Number one, it is a feasible solution, and second, it optimizes the objective function. Next, there were two types of the example problems in last four examples. First was the optimization problem in which there was no constraint. Such problems are known as unconstrained optimization problem. In our coming topics of linear programming, we will face maximally constrained optimization problem. It is very difficult to see an unconstrained optimization problem, especially in linear programming. So we, in further discussions, we will not referring the optimization problem to be unconstrained. Then next definition is actually our most desired definition, that is constrained optimization problem. The optimization problem that involves at least one constraint is called constrained optimization problem. So this is the last one is the actually the type of optimization problem which will be dealt in linear programming. Now, what is actually unconstrained problem? That are two first example in which we were asked to find maximum or minimum value and no additional condition was given to be satisfy the variable or variables. And the second, third, and fourth examples were constrained. And the constraints were here in example number 3 was only one constraint, that was x was bound to stay within the bound 0 to 2 pi. And in second example, the only one constraint was there, that was x plus 2y must be equal to 7. So these are examples of unconstrained problems and constrained problems. Now, what is linear programming? Actually, linear programming is a technique or set of techniques of solving such optimization problems that consist of linear objective functions and linear constraints. So all the problems in which the objective function as well as all the constraints are linear functions. What we mean by that? We mean that the variables appearing in the objective function and all the constraints appear with raised to the power 1. Here is an example of linear programming problem in which we have variable x1 and x2 with raised to the power 1. 5 and 4 are the objective function coefficients. And the formulas written on the left-hand sides of inequality constraints are also linear functions. So in linear programming, the objective function is a linear function, and the constraints, especially on the left-hand side, we can see only the linear functions of the same variables which are present or which are modeled as decision variables. The problem may also have three variables, and we can see the problem here in example of minimization of z, which depends on the values of x1 raised to the power 1, x2 raised to the power 1, x3 raised to the power 1. And the left hand sides of these inequality constraints, first and second constraints are greater than equal to type constraint, and third constraint is less than equal to type constraint. There may be several variables because in the real world problems, when we prepare a mathematical model of the problem, then there may exist 3, 4, 5, and hundreds of variables. So the problem can have very high dimensions as well due to the involvement of several variables, several decision variables. So general form of linear programming problem is to maximize or minimize a linear objective function involving n variables. Here C1, C2, C3, and so on, Cn are the constants and are called objective function coefficients, also known as objective parameters. And in the constraints, we can have a constraint involve linear constraint involving less than equal to or greater than equal to or equal to sign. Right hand sides are all real numbers and left hand sides are functions, linear functions of the variables x1, x2, and so on, xn. Here a set of n m linear inequality constraints or equality constraints is given. In addition to these constraints, we we may also be informed that some of the variables are non-negative. They satisfy non-negativity condition, but some variables may be may have no information in the model, and we there are actually techniques which can handle the such problems in which there is no information of positivity or non-negativity of the decision variables. So this has three main parts, that is linear objective function, linear equality or inequality constraints, and non-negativity information or constraints as well. Now, what is the objective of linear programming technique? The target of linear programming technique is to find such a combination of the values of variables x1, x2, and so on, xn, which satisfies two conditions. Number one, it satisfies all the constraints, means it is a feasible solution. Number two, along with being feasible solution, it also maximizes or minimizes the objective function. And how it is done? There are several methods in linear programming. The first of them is graphical method. Second is simplex method with M technique, simplex method with two-phase technique, dual simplex method, and revised simplex method. This is a list of 6 most popular methods. There are also some other methods, but we will focus on these 6 methods at first hand. In coming lectures, we will go into the complete and thorough discussion about these methods, how they are, how they work, and how a problem, what kind of problem is suitable for which type of the method. The first method, in a general look, we should have a basic knowledge about these methods. Graphical method is the method which actually visualize all the constraints and objective function and all the non-negativity constraints graphically. So it will work on a problem in which number of variables only 2. And second is simplex method. It works whenever the number of variables is 3, 4, 5, and so on. It can also be applied to the problem on which graphical method is applied, but simplex method does not draw any kind of plots of the constraints or objective function. The standard form for simplex method, the standard form of linear programming problem for simplex method is that it should be a maximization problem. All constraints should be less than equal to form, and all variables should satisfy non-negativity constraints. Next two methods, simplex method with M technique and simplex method two-phase technique, they actually are used when the problem of maximization and minimization involve one or more greater than equal to type constraint or equality type constraint. Then simple simplex method cannot be used. Next method, dual simplex method, is actually method which deals with the duality theory. In this theory, we prepare a dual linear programming problem and apply dual simplex method. The foundation of dual simplex method is also actually adopted from simplex method. Next method is revised simplex method, which is actually upgraded simplex method, and it is an efficient solver and works in a good speed and with high accuracy. So these are the methods, and this is the introduction of linear programming. In this lecture, we actually were aware of solving problems of maximization, minimization, but we didn't name the terminologies involved in the maximization, minimization process, and which were done with the help of calculus. The same ideas were there, but they were not important to remember. But now in linear programming, they will be frequently used whenever solving or modeling the problems. Hopefully, this video will be helpful for understanding the true spirit of linear programming problems. Best of the luck for the next lectures.